Alright, so we're starting AN2, okay, and we're looking for the difference between a rational number and an irrational number. So first of all, your teacher should have told you that a rational number is a number that can be written as a fraction. So the minute the number can be written as a fraction, then it is a rational number. But what happens if I give you an example like this? How do I write that as a fraction? It just gets a little complicated. So we give you another method using decimals. So two things for the rational number. If it is a finite decimals, meaning it ends, the answer it ends, then that is a rational number. And a repeating decimal can also be a rational number. So if I ask you this, okay, and I say, is the square root of 6.25 a rational number or an irrational number? You need to check on your calculator what the answer is. And if it's here, obviously it's going to be a finite decimal because I put it right beside it. But if I were to calculate the square root of 6.25, it gives me an answer of 2.5. So that is a finite decimals, it's a decimal that ends, and that is a rational number, okay? A repeating decimals, like 2/3, okay? 2/3 is, first of all, a fraction. So right there you could have known already that is a rational number. But if you're not sure, 2 divided by 3 is 0.6 repeated, okay? And so, of course, it's a repeating decimal, making it a rational number. If you look at irrational numbers, it needs to be an infinite decimal, meaning there's no pattern, it never ends, and it's basically not these two things. Alright, so if I do the square root of 4 over 5, what I'm going to do on my calculator is basically, first of all, find out what 4 over 5 is, which is 0.8. Okay, it was 0.80. And then I'm going to calculate the square root of 0.80. 0.8. And you get 0.894427. Blah, blah, blah. Okay, it keeps going, no pattern, so this would be an irrational number. If we look at the 4 examples here, okay, I want you to put them in either the rational or irrational box, and you'll see this basically this exact same question on your evaluations. Not the same numbers, of course. Alright? So pi, is pi a rational number or an irrational number? I'm going to check. What is the value of pi? Alright, pi is 3.141592654, and I know some of you already know that. Okay, so no pattern, okay, it doesn't end, it's an infinite decimal, so it would be in irrational. So you just put it under irrational. The next one, I want the square root of 144 over 121. What I want you to realize about this question is that if you were to press 144 divided by 121, you'd get an infinite value, an infinite decimal. When you square root that, then you would get a pattern, a repeating decimal, okay? The problem is, how can you put this division inside the square root if you have the same calculator as I have, okay? So, what I know is, from grade 9, is that when I have the square root of a fraction, I can do the square root of the number on top over the square root of the number on the bottom. So the square root of 144 is 12, and the square root of 121 is 11. Look at this, I'm ending up with a fraction, and if you were to check it, it would be a repeating decimal. So, the square root of 144 over 121 would be a rational number. The third one, it's a fraction. You don't even have to calculate it. It would be a repeating decimal, but it is a rational number because it's a fraction and also a repeating decimal. This one is a repeating decimal. You can't change it, you can't check it out, it's right there in front of you. So the fact that it's a repeating decimal, you need to remember that it is a rational number.